Hello everyone, and welcome to the Target 18 Part 1 homework review. So this is the first homework review based on the Part 1 worksheet of Unit 7, right, of Unit 7, and so let's get to work. So all these three problems come from the Part 1 worksheet. Hopefully the diagrams look familiar for you. If not, go ahead and reference that sheet. We're going to do problems 1 through 8. We're going to do 18B and 18E. So let's just get started. All right, so for the first 8 problems, and really it's all kind of like one problem, we have a diagram over here, and we just want to match our new vocabulary words to what it looks like in the picture. So let's just take it in order. So number 1, they are asking us, what do we call point D? So let's find point D. Here it is. It's just a point, that's why they're calling it D. And to me, this looks like a point of tangency, right? This line right here is hitting point D, and it's hitting that circle at just one spot, not going through the circle. We call that a point of tangency. And so we see the words point of tangency here. So we will write the letter E down on that blank. And I'm going to cross off E. I'm going to try to keep these pictures as clear as possible, so I'll make marks and erase them, move on to the next one, stuff like that. So here we go. The next one is talking about line FH. I know it's a line because of the arrows, so I need to include the arrows. And so if I look at FH, here's F, here's H, and it's a line between those 2 points, it's this line right here. And what this line is doing is hitting this circle at H one time, that's a tangent line, but it's also hitting this circle at F one time. So it's a common tangent line. So it's going to be one of these two, common internal or common external. And since it goes in between the two circles, right, in between, we call that an internal tangent. And so our answer for number 2 here would be G. So I'm going to write G in that blank. It is a common internal tangent. All right, clear this up. Next one. There's talking about segment CD. Segment means no arrows on the end, just starts and stops at point C and point D. So let's find that. Here's C, here's D. And what that is a segment coming from the center of the circle to the edge of the circle. We call that a radius. So that would be letter D here, a radius. Next one, segment AB. Again, no arrows. So starts and stops at A and B. So let's find A. Here it is. Find B, here it is. And remember, no arrows. And so this is just a segment whose endpoints are on the edge of the circle. We call that a chord. So letter B, and we'll cross it off. Next one is just a point, and it's point C. So we'll find C. It's right in the middle of this bigger circle. So that is the center of the circle, right? That's letter A, so we'll write A on the blank. Next one, AD. Notice, again, no arrow. So starts and stops at A and D. So here's A, here's D. So this is a segment whose endpoints are on the edge of the circle, but it also goes through the center of the circle. We call this a diameter. So letter C, cross off C, a diameter. Next one, AB, but this time with arrows. And so we find A and B, but we're going to talk about the whole line going through them both. We're going to include the arrows. And so this is similar to a chord. Remember, we answered chord for number 4. Segment AB, no arrows. This time we have line AB with arrows. And so this is a line that goes through the circle, hits it in 2 spots. We call that a secant. So we'll put an H there. And then we can clean this up a little bit, and we will cross off H, which means we definitely know 8 is going to be F, common external tangent. Let's see why. So this is line DE, so find D and E. Here it is. I'm going to highlight the line, including the arrows. And what this is saying is it's hitting this circle at D one time, this circle at E one time. So it's a tangent to both of them, making it common. And then it's external because it does not go in the middle. Remember, this is the middle of our circles, and it is not in between. And so that's why we call letter 8 a common external tangent. External means not in between. All right, perfect. So that's a review of our vocab. Keep reviewing it. You'll see this question a whole bunch this unit. Obviously, different diagrams each time. Now, 18b. So we just want to solve for x here, but we need to understand some properties of tangent lines. So it says, assume segments that appear to be tangent are actually tangent to this circle. Find the value of x. And so remember, when a line is tangent, so we're talking right now about where the 11 is, because a tangent line starts on the outside of the circle and hits the circle at only one spot. Does not go through the circle, it just brushes against it. It says assume that segments that appear to be tangent are, and so we're going to assume that's actually a tangent line. And when we actually have a tangent line, the radius and that tangent line, so the radius is where x is, and that tangent line forms a right angle. They are perpendicular, which means this is a right triangle, which means we can solve for x through a squared plus b squared equals c squared, which is our Pythagorean theorem. And so to figure that out, remember we need c to be the biggest side. That's across from our 90, so that'll be where 15 is. And so we just want to solve x squared plus 11 squared equals 15 squared. And so this will give us x squared plus 121 equals, and 15 squared is 225. And then we'll subtract 121 from both sides, and we'll get x squared equals, I believe, 104. Yes, it is. And then again, we never want x squared, we want x, and so we'll square root both sides, telling us that x is 10.2 if we round up, 10.2. And that's our answer. And we just use the Pythagorean theorem to solve that. And the reason we can do that, once again, is because tangent lines, like where 11 is, when they meet the radius at the point of tangency, they make right angles. Or a right triangle when we connect them, right? And every time we have a right triangle, we can do the Pythagorean theorem. Now, last piece of information that we need to get through today is this whole idea that if we have this external point, so that would be like point A, and we have a tangent line coming, two tangent lines coming from that point, so A to B is one, A to D is the other. So if we have two tangent lines coming from the same outside point, then those tangent lines are equal. So we just want to set 5x squared plus 9 equal to 14. And so we'll take 5x squared plus 9. It will equal 14. We'll subtract 9 from both sides. 5x squared equals, and 14 minus 9 is 5. We will divide both sides by 5. And we get x squared equals 1. And then lastly, we don't want x squared, we want x. So we'll take the square root of both sides, and x will equal. And the square root of 1 is just 1. And so x equals 1. And you can plug it back in if you'd like, just to verify that if we throw a 1 back into here, that side will come out 14, and 14 equals 14. So, all right, keep working hard. Let's move on to part 2 today. Email me if you have any questions. And thank you very much for everything you've done. Keep it up.